In the world of hypercars, audacious promises are common. But in 2017, Mercedes-AMG made a declaration that sounded impossible: they would put a genuine Formula One hybrid power unit into a road car. This wasn't merely F1 inspired, it was the actual engine from a championship-winning F1 car, repurposed for the street. The goal was to deliver an unparalleled driving experience, bridging the gap between motorsport's pinnacle and everyday driving. The ambition was immense, the engineering hurdles seemingly insurmountable. This is the story of how they defied physics, regulations, and expectations. The idea for the Mercedes-AMG One, initially known as Project One, was born from a desire to celebrate AMG's 50th anniversary and showcase Mercedes-Benz hybrid dominance in Formula One. The vision was clear: create a halo car that would stand as a monument to engineering prowess, directly sharing its powertrain with Lewis Hamilton's championship-winning W07 and W09 F1 cars. This wasn't about a loosely derived engine, it was about adapting the exact MGU-H-equipped, turbocharged V6 hybrid architecture. A direct transfer that would challenge every known automotive engineering convention. At the heart of the AMG One lies the M07 EQ Power Plus power unit, a direct descendant of the Mercedes-AMG F1 W07 and W09 engines. This 1.6-liter V6 turbo, combined with 4 electric motors, is a marvel of efficiency and power. In Formula One, it's designed for peak performance over a few hundred kilometers, operating at extreme RPMs. Its unique architecture includes a crankshaft-mounted MGU-K, 2 front-axle electric motors, and crucially, an electric motor integrated directly into the turbocharger, the MGU-H, which recovers exhaust gas energy and spools up the turbo instantly. This was the raw, untamed beast they aimed to streetify. Formula One engines are not built to idle. They are designed to run at high RPMs, generating peak power and efficiency only under extreme loads. A road car, however, must reliably start, idle smoothly in traffic, and accelerate predictably from low speeds. This fundamental difference presented the first massive hurdle. Furthermore, F1 engines emit raw, untreated exhaust. The AMG One needed to meet stringent Euro 6 emission standards, requiring a sophisticated and bulky exhaust after-treatment system that would typically choke a race engine. This meant a complete rethinking of the engine's low-end operation. Another major departure was the fuel. F1 engines run on highly specialized 102 RON racing fuel and boast incredibly high compression ratios for maximum thermodynamic efficiency. The AMG One, by contrast, had to run on standard 98 RON pump gasoline, available at any filling station. This required a careful reduction of the compression ratio and significant adjustments to the engine mapping and combustion process to prevent knocking and ensure reliability with lower-octane fuel. Maintaining F1 levels of power and responsiveness while making this compromise was a delicate balancing act, crucial for road legality and customer convenience. The MGU-H, or motor generator unit heat, is a cornerstone of the F1 hybrid system, attached directly to the turbocharger shaft. It recovers exhaust heat energy, converts it to electrical power, and can instantly spool the turbo to eliminate lag. While revolutionary for F1, its design for extreme, short-term use made it incredibly fragile for a road car. Its high-speed operation, over 100,000 revolutions per minute, demanded absolute precision and robust construction for long-term street durability, leading to extensive redesigns. This component alone nearly led to the project's cancellation due to its complexity and cost for mass production. The Formula One turbocharger is a colossal unit for a 1.6-liter engine, designed to operate at searing temperatures and dizzying speeds. For the road, this presented multiple challenges: ensuring durability over tens of thousands of kilometers, managing the immense heat generated, and integrating it with emissions controls without compromising its lightning-fast response. The team had to re-engineer the bearings, introduce new cooling channels, and develop sophisticated controls to ensure the turbocharger could handle varied throttle inputs and extended periods of low-load operation without premature wear or failure, a stark contrast to its F1 life. F1 exhaust systems are simple, lightweight conduits designed for maximum gas flow and sound, with no emissions treatment whatsoever. A road car, especially one aiming for Euro 6 standards, requires a massive and complex exhaust after-treatment system. For the AMG One, this meant integrating 4 large metallic catalytic converters and 2 gasoline particulate filters into an already incredibly compact engine bay. The challenge was to achieve this without creating excessive back pressure, which would severely restrict engine performance, and to manage the extreme heat generated by these components, positioned directly behind the engine. F1 engines are typically started in the pit lane using external preheaters and auxiliary power units, ensuring they are at optimal operating temperature before ignition. They do not cold start in the traditional sense. The AMG One, however, needed to be started reliably and repeatedly by its owner, often from a cold state, without a team of mechanics. This necessitated an entirely new starter motor system, integrated into the powertrain, and a sophisticated preheating strategy for critical fluids and components. Ensuring instant, reliable starts, even after sitting for days, was a testament to adapting race-bred machinery for everyday usability. The F1 power unit generates colossal amounts of heat. While F1 cars have extensive cooling, packaging an equivalent system into a road-legal hypercar, complete with air conditioning and passenger comfort, presented an enormous challenge. The AMG One boasts an intricate array of radiators, intercoolers, and oil coolers, strategically placed throughout its body. Managing airflow to these components while maintaining aerodynamic efficiency and the car's aesthetic was a masterclass in compromise and integration. Every millimeter of space was utilized, requiring innovative ducting and heat dissipation solutions to keep the F1 heart beating within road parameters. A Formula One car is an auditory assault, a symphony of raw power designed without regard for passenger comfort. A road-legal hypercar, even one as extreme as the AMG One, still needs to offer a degree of refinement. Isolating the F1 engine's inherent noise, vibration, and harshness, (NVH), from the cabin while preserving its distinctive F1 soundtrack was a delicate balance. Extensive use of bespoke engine mounts, sound-deadening materials, and structural tuning was required. This process ensured that the driver experienced the thrill of the F1 engine, not its unadulterated, spine-jarring vibration and deafening roar. Perhaps the most fundamental challenge was durability. An F1 engine is built for a few thousand kilometers, often replaced after just a handful of races. The AMG One, as a street-legal vehicle, needed to offer a lifespan of at least 50,000 kilometers and adhere to reasonable service intervals. This demanded a complete re-evaluation of materials, coatings, and internal component design. Key components like the crankshaft, pistons, and valve train were subtly strengthened and re-engineered to withstand the stresses of everyday driving cycles and longevity, a monumental task that required countless hours of testing and simulation. To overcome these hurdles, Mercedes-AMG implemented ingenious solutions. The F1 engine's screaming 15,000 revolutions per minute redline was reduced to 11,000 revolutions per minute for the road car, still stratospheric but crucial for longevity in meeting emissions at lower speeds. A new crankshaft and strengthened internal components were designed to handle these adapted stress cycles. Crucially, the AMG One effectively runs on twin electronic control units, ECUs, one managing the raw F1 engine parameters, and another overseeing roadcar-specific functions like emissions, idle, and driving modes. This dual-brain approach allowed the F1 core to remain largely intact while being seamlessly managed for street compliance. The 4 electric motors are central to the AMG One's street-legal success. The MGU-H, while challenging, remains critical for instant turbo spooling and eliminating lag. The crankshaft-mounted MGU-K delivers immediate torque fill, while the 2 front-axle motors provide independent torque vectoring and all-electric driving capability. This complex hybrid system allows the AMG One to start silently in electric mode, drive short distances emissions-free, and seamlessly blend electric and combustion power for truly instantaneous response and relentless acceleration. It transforms the F1 engine's raw aggression into a sophisticated, drivable hypercar experience. The sum of these extraordinary efforts is a powerplant unlike anything else available to the public. The Mercedes-AMG One is not just a car with an F1 engine, it is an F1 engine that has undergone the most rigorous, expensive, and innovative transformation in automotive history.
No other manufacturer has dared to integrate an MGUH-equipped F1 engine into a road car, let alone bring it to production.
The sheer engineering audacity to overcome every regulatory, reliability, and usability barrier makes its powertrain a singular achievement, a testament to what is possible when a clear vision meets unparalleled technical expertise. With 1,063 horsepower and a top speed electronically limited to 352 km per hour, the AMG One's numbers are staggering. But it's the technology, the blend of motorsport's most complex hybrid system with road car necessities, that truly sets it apart as the most technologically advanced hypercar ever built. Active aerodynamics, a full carbon fiber monocoque chassis, pushrod suspension, and the unprecedented integration of its F1 powertrain define its status. It represents a pinnacle, a bridge between two worlds that were never meant to meet, proving that with enough ingenuity, even the most extreme racing technology can find a home on the street.
The Mercedes-AMG One is more than just a car. It's a monumental engineering achievement that pushes the boundaries of what's considered possible in automotive design.
It serves as a real-world validation of Mercedes-AMG's dominance in hybrid powertrain technology and a powerful statement about the future of high-performance vehicles.
Its existence challenges conventions, inspires innovation, and demonstrates that the cutting edge of motorsport can, with immense effort, be translated into an exclusive, yet road-legal, package.
The One stands as a testament to human ingenuity, a beacon for future hypercars, and a dream made real.
The journey of the Mercedes-AMG One from a Formula One Pittsburgh lane to public roads is a saga of ambition, immense engineering challenges, and ultimate triumph. It stands as a testament to Mercedes-AMG's unwavering commitment to innovation and performance.
They didn't just adapt an F1 engine, they reimagined what a road car could be, integrating its ferocious heart with the demands of everyday drivability and strict regulations. The AMG One isn't just a hypercar, it's a living legend, a rolling laboratory, and a profound statement that the impossible is merely a starting point for those brave enough to try.